Hi, I'm Maggie Jarboe. I want to welcome you all to this great talk by Darren Lowry. Darren has been very helpful to the Tunnel Water Museum in sharing a lot of his resources. Today, he'll be talking about a lot of the information which is contained in his book, which will be available at the museum, which is the legacy of vanished island landscapes. And so he'll be going into some of the background of this today. And then this Friday, we'll have the opportunity to come and visit the museum from 1:30 to 3. So you'll have an opportunity to do a tour of the museum, which will include a lot of history about the various exhibits that talk about not only the evolution of the island and shrinkage of the island, but also who owned the island, because there are many different people that owned it and why they bought it, what they thought they were going to do with it. And then further, as you go through the exhibit, there were 3 different lighthouses on the island, a little bit off the island, and how they got eroded. So I think you'll all enjoy the exhibit. Just opened last weekend, so you're going to be early on to see what's going on. And the buzz is very positive. It's a fun place to be. And further, I'd like to introduce Marion Kellogg, who started the Tunnel Water Museum, and Chuck Powers, who's our present president of the museum, and Bonnie Messick, who's our curator for this wonderful exhibit. So with that, I just want to give you a little bit of background of Darren Lowry, because Darren grew up on Tillman, and early on, he and his father used to hunt arrowheads on Sharp's Island. So many of these wonderful exhibits that he has came from that fun exploration with his father. That piqued his interest, and he actually has graduated magna cum laude with a BA degree in anthropology from the University of Delaware, and then went on to get his PhD from the University of Delaware, specializing in geology and geoarchaeology. So that's quite a background, and we're thrilled to have Darren take over at this point.
So,
okay. Hopefully you can hear me. Oh, wait. Okay.
Okay. So, is this on? Can you hear me? Okay. So I'm Lynn Randall, Executive Director, and I wanted to give you just a quick little administrative background for this kind of a course. Since Darren is coming in through Zoom, it's hard for him to hear us if we ask a question in the middle. So we'll save the questions till the end, and each of us will use the microphone for our questions so that he'll be able to hear us. I would also add that if you can avoid having little side discussions while this is going on, it'll make it a lot easier for him. So thank you. And Darren, thank you again. It's wonderful to have you today.
Well, I appreciate the accolades, but I do have to make one correction. I never walked on Sharp's Island. I'm not that old. My father did. So I would have loved to have been around when it was still an island. But unfortunately, it had disappeared before I became onto this planet. So that's the only correction. But otherwise, today I get to talk about a topic that began when I was a kid, walking shorelines, and then it culminated into ultimately using the information that I'd gleaned to get a PhD in geology, mainly coastal geology and geoarchaeology. And hopefully I can kind of rectify some of the issues, and we'll start this presentation. Hold on here. I wonder why it's not working. Okay, let's click on it. Oh, there we go. Okay. This is an image of a process that you see. It's very common around the Chesapeake Bay, that landscapes that were utilized by people either historically or prehistorically have been disappearing. And this is one island or one landscape that is now gone. You can see in the upper left-hand corner what was James Island. Prior to that was James Point. It originally was about 1,000 acres in 1847. And as of this lecture, it's gone. And you can see the process of erosion and land loss. But more importantly, with respect to those that are, equate erosion and sea level rise as interconnected, which they are not. Usually the last fragments of any of these landscapes, be they James Island or anywhere else, are usually the tidal marsh, which is the topographically low section of any landscape. So in theory, if it's sea level rise, you would expect the low areas to disappear first and the high areas to disappear last. And actually, coastal erosion is much more effective when sea level is constant. And we'll get into that later on. This is another thing that you see in the public media hype. Sea levels don't come up. I mean, the greatest rate of sea level rise in the last 24,000 years was Meltwater Pulse 1A, and sea levels are rising about 13 feet a century. That's pretty rapid. But one of the things words that I really detest, and I see it all the time, and I think it's because people don't understand the process, is the word sinking. It gives you the impression that the landscape is sinking, and in some cases you can have sinking landscapes. But that's the same word you see a century ago here. You can see these are newspaper clippings from the turn of the century talking about Chesapeake Bay island loss. So it's not unique to today. People, 120 years ago were talking about it as well. But the term sinking has a bad connotation. When something sinks, it usually remains intact on the bottom, like this ship here. When you're dealing with coastal erosion, when an island sinks or island gets eroded or a landscape gets eroded, nothing remains intact on the bottom. And this is what it looks like. And today I'm going to talk about a bunch of locations on the map in the left, but to illustrate that process, here is a section of Parsons Island, and the upper picture on the right was taken in 2013. And you can see a historic well. That's a feature. That's an archaeological feature. It dates to the early 19th century, maybe late 18th century. As of 2024, that shoreline had receded, and that well has been bulldozed away by wave energy. So it didn't sink, it got bulldozed away by what wave energy and water processes do to these landscapes. And to illustrate that sinking is not an appropriate term, I picked an island that, that's near Parsons Island. And this is a map, a cartographic map, probably some of the best maps of the bay earliest on that show accurately the landscape. This was done around 1846, 47, and I will use Bodkin Island. And Bodkin Island is essentially gone as well, but you can see at Bodkin Island, it's in the lower right-hand image, was an upland. It had tilled landscape. There were some structures out there. We're going to carry Bodkin Island through time. The next cartographic maps were done around the turn of the century, around 1900, and you can see it shrunk some. It still has an orchard on it at that time. Now we're going to zoom into the earliest good aerials of Bodkin. So we're going to take that square map or a square box and zoom in. And this is what it looked like in the 1950s. And you can see that it has broken into two pieces. There's a long skinny piece off to the north and west. And then there's this southern chunk, which was forested at the time. And then we're going to jump further into time. And I can't read the date because the Zoom thing, but it's around, 2013, 2008, something like that, 2008. And you can see what has happened. Somebody has built a cribbing around it. And you can see this elevated fragment inside of it. And if you were in a boat around 2008, looking at Bodkin Island, this is what you would see. You would see the cribbing. You would see this elevated sort of plateau thing with a few dead trees and a lot of cormorants on the island. The cormorants contributed to the death and dismay of the trees. But we're jumped through time. the cribbing is there, the bulkhead is there. So what happened to Bodkin Island? And here it is in 2022. You can see that upland sort of plateau terrace thing has shrunk, but the cribbing is still there. Here it is in 2023. It continues to shrink, but the cribbing is still there. And by late 2023, Bodkin Island is gone. So if Bodkin sank, why didn't the bulkhead sink? And the reason why the island disappeared had nothing to do with sinking. It had to do with this. It had to do with its geology. Bodkin Island, like many islands, Sharps, Tillman, Poplar, James's, Parsons, consists of wind-blown sediments that blew up at two different intervals in the last 125,000 years. The most recent one was around 12,006 to 11,600 years ago. And these sediments have weathered in place. So they blew up, they accumulated, they stayed there, and they underwent what is called pedogenesis. They became actually a soil. And because they underwent that, they have certain structures. So when this island erodes, it breaks up in blocky chunks. And you can see they look like boulders, but they're not. They're just chunks of silt and clay and loam. The clay accumulated over time, and it increases the surface area. So when water comes inside of that cribbing, which you can see here, a little bit of that surface of that chunk of Bodkin Island becomes emulsified and turns into a slurry. And by 2023, this is all that was left. And we can see this process of emulsifying and sort of being turned into a slurry by this image. This is James's Island, or a portion of James's, in 2013. And you can tell that it's flood tide because you can see the mud streak being carried off towards the north and east in this picture. Now we're going to zoom in, we're going to move through time, and we're going to see James's through time. Note that it's not a rough day. There's not wind and wave activity. This is just the ebb and the flood of tide carrying this island away. These mud streaks here probably have many 5-gallon buckets of sediment being carried away from that island. So we're going to jump through time. Here's that same island in 2022. Now, it's a little bit rougher that day, but you can see the same process. It's flood tide, and you can see these mud streaks of James's Island being carried off like a slurry just by the daily ebb and flood of tide. So the curse of James's Island is its geology, and the same thing with Bodkin Island, same thing with Sharps Island. You can see that if you're standing along the shoreline. This is the northern end of Taylor's Island. You can see James's in the background when it was there. You know, it's gone. There's nothing left. But you can see that process in action. You can see the sediment, silt being carried by the flood tide here. And it doesn't seem like much, but a 5-gallon bucket of sediment twice a day from one little point or promontory adds up over time. So today we're going to talk about islands that have disappeared to illustrate that coastal erosion is not unique to today, and island loss is not unique to today. If you look at the media and you look at the published literature, you give the impression that, you know, this land loss is something that's happened in the 20th century and 21st century, and that's not the case. It's just that we have a lot more documentation and recordation that has occurred in the last 100 years. This is Watts Island. Watts Island's a location in Virginia. It's much like Sharps Island. It's stuck out in the middle of nowhere. I don't know how many people in the crowd has ever been to Watts Island. I've been there several times. It won't be much of it left, but you can see what it looked like in 1850, and then you can see what it looked like in 2013, I think. And then you can see a picture of me. I'm on the southern end of the island. This is over a period of an interval of time, and you can see what's happening. The island's, you know, eroding away. Watts Island, this is a picture that was taken in 2019. I went out there about a year ago, and it is much more reduced in size. Watts Island, like many landscapes, have early histories. So people were out there, in the 17th century. They were plotted on maps. You can see this is the Augustin Herman map of 1670. You can see Watts Island. But it has a longer history, and many of these islands have long, long histories. Watts Island has archaeological remains of people being out there 13,000 years. Now, it wasn't an island 13,000 years ago. We know that because sea levels were a lot lower 13,000 years ago. But someone asked earlier on, how do I know that some of these artifacts are 13,000 years old? Projectile points like anything, like cars, and I always use cars because most people see a lot of cars on a daily trek through Easton or anywhere in Talbot County. If you see a 57 Chevy, you know it was built in 1957. If you see a Volkswagen Bug, there are newer versions, but the old ones, they were made similar over a long period of time. So these stone projectile points, some were made during very restricted periods, some were made during very long periods. Now, why would people be out there on this island for the past 13,000 years? And again, it wasn't an island, it was a peninsula. And you can see in the bathymetry map in the lower right-hand corner where Watts is situated. To the west, you had Tangier Sound. To the east, you had Pocomoke Sound. There was a deep valley there. So when sea levels were lower, Watts Island was an upland peninsula with fresh water to the east, fresh water to the west. And as sea levels rose, that peninsula got broken in two by wave energy, and then it became an island. So the later folks living there would have seen something analogous to what we have today with a bigger landscape. But the earlier folks, it would look kind of completely different. What about other islands? We're going to focus on this one. This is Hollands and Long Island. Here, Hollands Island reached some notoriety in the published record about using the house as evidence of sea level rise. I'll break it to you bluntly. Houses have been washing away in the Chesapeake Bay for a very long period of time. We'll show you some. Hollands, everybody, thinks Hollands is the ridge to the east. Actually, originally Hollands is the ridge to the west in this image here. It's duly marked. The location to the east was originally called Courtney's Island. But I want to draw your attention to another island that exists that disappeared a long time ago. It's called Long Island. And in 1849, it was a substantial chunk of land. It was about 32 acres. It was tilled. There's an orchard there. There's a house there. But in 1680, when it was first patented, it was over 400 acres. So between 1680 and 1849, about 368 acres of land had already eroded. So prior to the 19th century, erosion was occurring. And we're going to do, I'm going to show you all these arrows in a minute. We're going to focus in on it, but focus on Long Island. We're going to go to 1901. You can see by 1901, it was down to 6 acres, still had houses out there. But we're going to jump over to the arrow there that has a star. That is Hollands Island proper. You can see a photograph of houses. There was a street, and there were lots of houses out there on Hollands. And then we're going to jump over to the cemetery. The cemetery on Hollands Island is where the star is there, and it's still there. But note that Long Island is gone by 1942. It has disappeared. So that 400 plus acre tract of land that was patented in 1680 has now succumbed to wave energy. So now we'll continue to the house. This was the last house that reached some notoriety in the media. You can see what it looked like in 1989. Here's what it was in 2013. And of course, it succumbed to wave activity and tidal action, and it fell into the Chesapeake Bay. However, I draw to your attention that probably occurred on Long Island maybe even a century beforehand. So now we're going to jump to other islands that you've never heard of, and I'm going to give credit where credit is due. Cindy Smith, she helped out on a lot of this through our correspondence. There's an island in western Talbot County that wasn't much to look at. It's called Impey's Island. And Impey's Island in 1848 was nothing but two little teeny tiny chunks off of a point called Bald Eagle Point. However, in 1830, it was about an acre. So somebody wanted it. There was a patent or somebody paid taxes on it and they wanted it. But even by 1846, it had largely gone by the wayside. So Impey's Island had already succumbed and it disappeared in the 19th century. So the next map, coastal survey map, doesn't show a thing there. So this landscape could have been bigger even before 1830, but we don't have much information about it. Next location is a precarious island called Herring Islands out in the middle of the Miles River. Herring Island, you can see it up here on the left. It's literally, quite literally, stuck out in the middle of the Miles River. Not a good place to be, especially during a northwest gale. This is a map that was done in 1846. You can see Herring Island. It was mainly tidal marsh. Then, maybe with a little bit of upland there. But what was herring back in the 17th century? It was 75 acres. By 1869, it was down to 4 acres. So 71 acres of land disappeared over that duration of time, had eroded into the Miles River. So erosion was happening even in the 17th and 18th century. And so it was 4 acres. You can see it was defined as upland, this cartographic survey. And then by 1937, it's gone. It's disappeared. We'll go to another one. There's a creek just to the east of Oxford called Island Creek. Is there an island on Island Creek? Is it the world's biggest cartographic oxymoron? No, there was an island there called Goldsborough's Island in 1826. It was 11 3/4 acres. So the creek its name is a vestigial holdover of when there actually was an island, but it had disappeared even by 1846. We'll go to another one, Royston's or Aldern's Island, because the name changed. Royston's Island in 1846 had a lot of upland, had some orchard there, had some tidal marsh. By the turn of the century, it had been reduced to nothing but just tidal marsh. And by 1957, it had disappeared. Originally, it was called Aldern's Island, and it included 41 acres back in the early portion of the centuries, in the 17th century. So this brings us to the island of topic. Nowhere in the Chesapeake Bay has there been any greater erosion than that noted for Sharp's Island. It has some mystique because it's got a deep-seated history. We know that people were living out there, both Native Americans and historic folks of notoriety. The first map that actually recorded its location was the map generated by John Smith based on his June 1608 exploration of the Upper Bay. His orientation of the map is different than what we would have today. However, if we orient it the right way, we can see that it matches up quite well. He called it the Winston's Isles. It was the lower end. And you can see how the one arrow there denotes the little Choptank. And then you can see the other arrow denotes what would be James Island or James Point back then. And there's this big amoeba-shaped blob. The island was so big that he couldn't even perceive the mouth of the Choptank River. He's sailing up the west side of the bay at the time, but he notes it's a big landscape. And for all intents and purposes, it was about 1,400 acres or more at that time, 1,400 acres of land. And in 1608, when there was 1,400 acres of land, today there's nothing other than that lighthouse off in the distance. This is another common misnomer. People think that the lighthouse there today denotes the island. Not so. Actually, it was to the south of that by about a half a mile, or at least the last vestigial remnant of the island. By 1673, the island encompassed about 900 acres of land. That's a loss of about 7.7 acres per year. This map, which was done in 1670, is the Augustine Herman map. This is the first map to denote the name Sharps. Prior to that, it was called Claiborne's Island, probably named after William Claiborne, who had also had settlements on Poplar Island and Kent Island. By 1798, when the tax maps were first generated, Sharps Island was about 700 acres, lost about 1.6 acres per year. Here's a newspaper article to talk about when the British invaded the island in 1814 or the War of 1812. But here's a map also about the same time, and you can see that they denote Sharps Island, but there's something else they denote. They denote two islands there. They denote the big island and this little one off to the east. That'll be important. The best survey ever done of that island was done in 1848. And this survey gives us a glimpse into what that landscape looked like. The island in 1848 was 438 acres of land. Between the last survey and this survey, it's losing about 5.24 acres per year. But if we zoom in on these maps, we can see some information. First of all, they denote where the first lighthouse was. The first lighthouse was on the northern end of the island, northwest end of the island, called Drum Point. And on this map, which was later somebody noted, is that it was destroyed as a byproduct of erosion. And then they constructed the second lighthouse offshore, and you can see that one, New Lighthouse, denoted there. But if you look at these maps, they tell you what was tilled, what was forested. So we'll move, and where people were living. Here's where the people were living in 1848. There's a house there. There's several outbuildings. There's an orchard. There's a road that goes to the west side of the island, probably to get firewood. And if you look down to the southeast, you'll see sort of a stream or a little creek gut or a little ditch. But they named that point Little Island Point. And that probably is a vestigial name holdover when there was a little island there. By 1848, that little island that was plotted on that 17th century map, or 18th century map, excuse me, had long since disappeared. But the name records its location, Little Island Point. And that ditch that you see there will become important in the history of the island. So we go down the lower end of the island, and you can see it's predominantly tidal marsh. There's a sand beach, a little spit that had formed of accreted eroded sediment. And they even denote a duck blind there, and it's called Beach Point. So we get a glimpse of what this landscape looked like. We also, in this map here, it's a little, I probably should use a higher resolution one, but you get an idea of how big that island was. There's Tillman to the north. You can see how big that landscape was. Now, this map was published in 1890. And by 1890, Sharps Island didn't look like that. But what they did do is they plotted the last lighthouse. And you can see they plotted the 1848 coastline, but they plotted the most recent lighthouse, the one that's there today. And you can clearly see that the lighthouse was not on the island. It was a good ways offshore. But when you're out there in a boat navigating the Choptank River, try to imagine or envision a landscape this size out there with tilled fields and forest. We also have information about the first lighthouse. This image down below, you've got the 1840 map up here at the top, oriented in a different direction. But if you were coming up the bay in 1848 looking to the east, this is what you would have seen. The lower sort of illustration there shows a boat view, a navigator's view of Sharps Island. And you can see, first of all, you can see the lighthouse here. There's the lighthouse that was on the island. You can see the forest to the south. You can see where it opens up the tilled fields. You can see another grove of trees. You can see a little bit of the marsh. So this is the only glimpse we have that was ever published that shows what Sharps Island looked like if you were in a boat in the mid-19th century. This is what that first lighthouse looked like. Cindy Schmidt did a reconstruction of it based on written accounts. The lighthouse was on wheels. And the reason why it was on wheels is because even then in the 19th century, they realized the shoreline was eroding and they periodically had to move it so that it didn't disappear or erode into the Chesapeake Bay. And I'm pretty sure in the information at the museum, there's some testimony about the island or the lighthouse almost eroding into the Chesapeake Bay. And they say, fortunately, the winter we didn't have ice, and the lighthouse still survives. They recognize that ice was a formidable foe, and it is. We have other accounts. By 1870 or so, the island was about 300 acres. But we have testimony written by Margaret Stevens Parsons. She was a girl living out there in 1876 when the Centennial Storm slammed into the Chesapeake Bay. She wrote, "We stood on our porch and watched the waves smash over the pines, and the tide got so high it ran through a ditch and cut the island in two during this storm." And the ditch is this ditch, because it's the only ditch on the island. And you can see, if you overlay this map with the next survey, which was done around 1900, the scar of that Centennial Storm. We're going to fade out. So the storm got so high that the waves broke over the island and literally scoured that landscape and brought it down to sea level. So when you see this map from 1900, it shows tidal marsh where, if we go back, there was plowed field. By 1900, when this map was produced, Sharp's Island was down to 90 acres, 7.7 acres of land loss per year since the previous survey. We have our first photographic glimpses of what was out there. We know that there was a hotel, a failed business venture. I'm pretty sure there's a lot of that information. We can see the steamboat wharf. It was plotted on there. You see these weird circles with a triangle. That's a triangulation marker that they use to map the island. And you can also look on the left-hand side, and you can see some other details. You can see where there's marsh. You can see where there's a sand spit. You can see the wharf, the steamboat wharf, and you can see the houses that were out there, the leftover houses from earlier occupations, as well as the hotel. And again, it was a grand hotel. It was wasn't used much. And we have several published pictures. There's the one on the upper left and the one on the darker one on the right. It was two porches, elevated up. They said that it could easily house 75 people. And then we have photographs of some of the only people to ever enjoy that landscape. There was a fishing club from Talbot County that went out there. And in the one photograph, you can actually see the steamboat wharf in the background. So the map on the left-hand side shows the island, and it shows the three lighthouse position. The one that was on the island, and then the one that was constructed after that got destroyed in after 1866, and then the last of the Mohicans, the one that's currently there. And you can clearly see that the current lighthouse was never on that island, or at least wasn't on that island in any mapped form. Maybe the current lighthouse would have been dry land sometime in the 1500s. And we're going to further erode Sharps. We're going to go from 1900 to 1937. And you can see by 1937, it was only 13 acres. It's mainly tidal marsh at that time. This is an aerial photograph of that island, 1939. It's looking from the east side, looking west. North end would be on the right side. South end would be on the left-hand side. At this time, the United States Navy was using it as a bombing practice range, and they were also using it as for machine gun targets, using 50 caliber and 20 millimeter cannon rounds. It was at this time that a lot of folks, and even prior to, from Tillman went over there and started to collect artifacts that had washed up on the beach or marsh. We have photographs of that. This is a photograph that Bonnie provided. It's her grandfather in the back. It's her grandmother in the front. Most of these people we know, and that's my father in the lower left, standing up right there. So we have a deep-seated connection to some of these people. And actually, I got to give Bonnie's grandfather a lot of credit and grandmother a lot of credit, because it was in 1977 that I got a chance to look at the artifacts that they had collected. I knew what my father had found, and it was absolutely stunning. There were literally tens of thousands of projectile points collected from the shoreline of Sharps Island before it disappeared. There's even a narrative, a written account of a Boy Scout camp that sailed out there in the early portion of the 20th century for the sole purpose of going to look for arrowheads. So clearly everybody in the region knew you could go out there and find a ton of stuff. I do remember my father saying that when he landed there, he said, everywhere you look, you had seen arrowheads. I didn't believe him until later on I found a site down in Virginia that gave me the same sort of quantity. So now we're going to go from 1938 to 1948. By 1948, it was down to about 4 acres, thereabouts. So you can see clearly that the last remnant of the island was tidal marsh, the topographic low section, not the high section, the low section. We do have an aerial photograph. I loaned this to the museum. I think they got it down there. This photograph was taken on September 21st, 1946. You can see the trusses from the old steamboat wharf in the lower right-hand corner of the photograph. You can see to the north, those plywood structures are the Navy bombing targets. You can also see a couple craters there. Rumor has it they used a few bigger bombs to drop on the island. Most of them are just target bombs. But we also have a map that was created in 1948 by the United States Navy to denote the property. You can see it had a similar shape, but it eroded a little bit between 1946 and 1948. The last photograph we have is 1952. It's a blurry photograph with a lot of dust specks on it. This is at the National Archives at College Park. Then there's a 1953 photograph. I think that is Bonnie's grandfather's boat in the backdrop. You can see one of those Navy bombing targets, and it said it was a thin strip of nothing in 1953. And for all intents and purposes, from the comments of 2 individuals who were watermen at the time, one was older, one was younger, the island disappeared in 1954. So Sharps Island lost its 346-year battle with the Chesapeake Bay in 1954. And all the maps since then just show an obstruction. It's probably not much of an obstruction there. And they show submerged pilings, and these would be the pilings associated with the steamboat wharf. So just to give you a history, this overlay on the right shows the erosion history of that island. And you can see some patterns here. First of all, it's asymmetrical. The erosion is happening more on the north end and the west side. The east side is largely spared, and that's probably due to wind direction and storm activity. You know, if you have waterfront property, you realize that most of the storms come out of the northwest and southwest. So not surprisingly, Sharps Island's shape and erosion history reflects that. But more importantly, this dire sort of like predictions of the future. This article in 1907 predicted, and this is based on the testimony of a professor at Johns Hopkins, that 6 islands will disappear in the next century. And the islands mentioned included Hooper's Island, Kent Island, Sharps Island, Barren Island, Taylor's Island, and Holland's Island. Of those 6, only 1 disappeared. Holland's is still there. So the point being here, the dire predictions, the sort of sky is falling media hype, failed to accurately predict with any degree of accuracy the number of islands that would disappear. And why did they do this? Well, first of all, most of the people that predicted that dire sort of end of these islands are now pushing up their own daisies. So there's no ramifications for them for making a bad prediction. So why did Sharps Island erode away at such an alarming rate? And it's a combination of factors. And it's a great example of that because we actually have narratives of people going out there trying to understand why is this island eroding. So we'll get to that. First of all, it's geology. This is written in it was published in 1914, but the information was gleaned in 1911. It says the northern part of the island is made up of the Talbot Formation, which is a silt loam, and rises out of the water as much as 7 feet. Here, the erosion has been enormous. This gentleman here, J. Fred Hunter, was hired by the USGS, U.S. Geological Survey, to go out there and deal with that. This image here probably is what you would have seen, or what he would have seen. He said, and I quote, the marshland on the southeast side of the island, or east side of the island, is resisting the erosion much more effectively than the rest of the island, and it will doubtless be the last to disappear. Boom, he nailed that one. Tidal marsh is nature's rebar. It is much more resistant to wave energy. And this photograph here it was taken in 1905. I'll give you an example of errors here, because there's a lot of published errors about Sharp's Island. This photograph appears online. I think it's NOAA, National Oceanic Atmospheric Administration, and says that this photograph was taken in 1950. And it shows folks going out there to document the presence of Sharp's Island before it disappeared. This photograph exists in the library, the Easton Library, and the the local manuscripts there, and it's part of a journal that was published in 1905. So this photograph was taken in 1905, August, September of 1905. So there's a lot of errors about Sharp's. The other thing that affects the reason why Sharp's Island disappeared is the particle size of the island. And I say particle size, I'm starting to get into a weird geology here, but you can pretty much break our coastline down into two things: sand or silt or tidal marsh. There are some areas where you have cobbles and whatever else, but the island wasn't made of sand. But there are landscapes that are around the bay that are made of sand. This is Savage Neck in Virginia, and it's made of sand, primarily the geology. You would think it would be heavily eroded, and it is. Sand actually can break apart pretty easily, but it's not held by the currents or the waves. It actually saltates or bounces on the bottom. So it doesn't float away. It forms these things that you can see offshore, which are called sandbars. And but Sharp's was made of this: silt, clay, and loam. And as a result, you can see this process here, which I showed you earlier. It gets emulsified by just current action, wave energy, and it literally floats away like a mud slurry. Fetch, the distance that wind travels across water, is a major variable too. And Sharp's had a lot of open water around it with a lot of wicked exposure to wave and wind directions. Bathymetry. Now, I threw this one here because you can see the island superimposed over a current bathymetry map. Now, remember what that USGS guy said, that the island stuck out of the water 7 feet on its northern end. Where there was 7 feet of land above water in 100 years ago, or 150 years ago, now there's 9 feet of water. So what's 7 and 9? That's 16 feet of sediment that got scoured away by wave action and tidal action. So when you have deep water adjacent to a shoreline, the wave energy as it travels across, the wave energy is not dissipated. So when it slams into that coastline, it's like a sledgehammer hitting a concrete wall. And you can see that here. This is Taylor's Island in 2011, Halloween actually, and you can see what's happening. It's not a particularly rough day. It's just that wave energy is hitting that shoreline with full force. And actually coastal erosion is very efficient, most efficient when you don't have any sea level rise or any change in level, because the sledgehammer is hitting the wall in the same spot time and time again. Now, when you have sand, like Savage Neck, Virginia, that sand is not carried away, so it forms these bars offshore. When I took this picture, the wind was blowing out of the northwest about 60 miles an hour. The fetch here is about 113 miles when the wind blows out of the northwest. So it's a massive fetch But here, what happens? The sandbar dissipates the wave energy. I'm standing right adjacent to the shoreline on the bay with a 60-mile-an-hour gale, and it's almost as calm as a duck pond. So that wave energy gets destroyed. As a result, Savage Neck has lost very little land in the last 150 years, unlike Sharp's Head. The presence of subaquatic vegetation, this is hard to predict because when I was a kid growing up early, I can remember it barely, and then it all disappeared, and now it's starting to come back. But the black arrow or the black triangle that's pointing to it shows what happens when you have subaquatic vegetation. Not only does it bond the sediments, but it actually dissipates wave energy. You can see it's a little calmer there. So when those waves come across the water and hits that subaquatic vegetation, the energy gets dissipated. So we don't know what the subaquatic vegetation history of Sharps was. Presumably it was there somewhere. Tidal amplitude. We don't think about this much. As you go up the bay, the tidal amplitude is lower than it is at the lower end of the bay. At the lower end of the bay, it's as much as 4 feet between high and low tide. The mean is 2. In the upper bay, it's about 1 foot. So the difference between high and low tide is about 1 foot. So therefore, the mean is 6 inches. When you have areas that have high tidal amplitude, this is down on the Machipongo River on the ocean side, which it does. Here it's about a 5-foot tidal amplitude. You can see here's an upland landscape. You can see trees that have been eroded. But meanwhile, because the tide is not high all the time and the waves are not hitting the shoreline in the same location, because of the amplitude, imagine the wave being a sledgehammer. The sledgehammer moves down that shoreline, and therefore it's kind of like moving a sledgehammer down a wall. It's not hitting the same spot all the time. The shoreline still erodes, but you get vegetation accumulation there because it's not a high energy environment. When you have low tidal amplitude, here's James's Island when there's actually a forest, this is all gone. But you can see the tidal amplitude there is about maybe 1.5 feet at the most, normal rate. So the wave energy is hitting that shoreline in the same 1.5 foot belt all the time. Again, particle size is silt. It's deep bathymetry. If you step off that shoreline, you're going to be up to your neck. So you've got bad geology, bad bathymetry, bad tidal amplitude. Seasonal presence of ice. We have the evidence at Sharp's Island of what ice can do, because prior to the 1977-78 winter, the lighthouse was vertical. During that winter event, the ice piled up on that lighthouse and actually tilted that caisson. And ice is a formidable foe. It is buoyant. Can be a battering ram, but it can also be like nature's giant knife, and it will cut a landscape off. And that's exactly what happened to Sharp's Island. The winter of 1954, the last remnant got cut off by ice. I've seen islands, when Poplar Island, before it became a big dredge spoil pile, I've seen islands literally disappear in a single winter just by ice cutting it off. So ice is a major variable. And if we look at the history of ice in the Chesapeake Bay, this is a hard chart to see. The point being is written accounts of ice are kind of spotty. So we don't have an accurate account. However, you go back through time and read newspaper articles about folks who ice skated from Baltimore to Annapolis to go to work. That usually tells you got a fair amount of ice. If you go back through time, you can see that the intervals of ice in the Bay Formation are probably somewhat inaccurate as you go back in time. But even if you take the written accounts, you can see that ice formation was much more prevalent prior to 1850 than it is in the last 150 years. And that may have explained why the island was eroding at such an alarming rate during the early portion of its history and human presence, European human presence. But it also correlates to a time period that geologists call the Little Ice Age. That's when folks were ice skating on the Thames River. And if you read some of the written accounts in the Chesapeake Bay, like I said, people regularly ice skated from Baltimore to Annapolis, and a lot of business folded up early on in Annapolis because the merchants couldn't get their boats out of Annapolis and they couldn't get shipments into Annapolis. We don't have that issue today. So Sharps Island had all the bad variables, it was like the perfect storm for coastal erosion. However, I'm going to show you, there's a great reference from this 1914 USGS guy. He basically made a prediction when Sharps Island would disappear. He didn't know the United States Navy was going to bomb it, though, which probably didn't help it out. But he said it may be of interesting connection to venture a prediction based on the facts at hand as to the time of the final disappearance of Sharps Island. At the rate during the last 10 years on the West Coast, the estimated date of disappearance is probably about 1950 to 1955. It disappeared in 1954. So he didn't evoke sea level rise. He just understood what waves do to landscapes, and he hit that one out of the park. Now, like many of the islands and landscapes in the Chesapeake Bay, they all have an archaeological record, and it has disappeared. In the case of Sharps, it's all gone. Presumably out there in the shoals somewhere are pavements of arrowheads that never got picked up. But a lot of these landscapes were occupied by people well before the Europeans came into the landscape. And this is the box of arrowheads that my father picked up that's on display. There are a couple things to note about this, and I noted this about Bonnie's grandfather's collection. There are very few broken projectile points in this collection, which means the broken things were thrown away. But in this collection, it's about 700 projectile points. We have the history of human use of that landscape, and it gets us to another concept of sea level. So we're talking about erosion and sea level change. So if you go through this collection, and granted, it's a small representation of what actually was there, you can break it down into types. And you can go to that map, or I can go to that map and say, okay, if I were a Native American and this island looked like it did in 1850, and the farmer out there was tilling the landscape, where would I find archaeological sites? All of those areas highlighted in red would be areas where you would find late prehistoric sites. That little blue line that I show going through Sharps Island is what is called the drainage divide. And the drainage divide is a great place to find early sites. And then more particularly around springheads. And remember Margaret Parsons' ditch? That's probably a springhead. So that would be a great place for an early site. And guess what? Sharps had a lot of early and late period sites and material on its shoreline. But how did all that stuff accumulate? Why was there so much stuff there in the early portion of the 20th century? Now, you got to take into consideration that this island has been continually eroding. So this is an imaginary cross-section of Sharps. So you've got time 1, time 2, time 3. There were archaeological sites there that eroded. Now, because artifacts, projectile points, arrowheads, are not that heavy, when the site washes away, the arrowheads or the artifacts continually move with the shoreline. The heavier stuff doesn't, like the axes and whatever else, but they continue to move with the shoreline. So by the time Bonnie's grandfather and my father went out there, the island's upland had long since disappeared. It was this low topographic tidal marsh with some little beaches, and the collective accumulation of archaeological sites of yore had washed up on those marshes. So you could find literally a pavement of arrowheads. And we can look at the assemblage and tell something about it. Some of those artifacts, like the one here in A, is so tumbled it looks like an artifact that's been a rock tumbler for months on end. You can't see any details. B got a little bit more details. It's got some polish to it. It's got dulled edges. C is sharp as a razor blade. You could still use that one. D here has undergone some processes that are unique to tidal marshes. So we can see all the key indicators that the artifacts that were collected in the turn of the century represent a long-term accumulation. Some had washed out probably a century or two before my father ever picked them up. Some of them washed out probably 3 or 4 days before he picked them up. And you can look at a modern-day archaeological site. This is the site down on down near Hooper's Island, and it's a Native American shell midden, and it is eroding out. And you can see what happens is that the stuff erodes out from the primary midden, and then wave energy just carries it up on the shoreline, and you end up with an oyster. In this case, it's an oyster shell berm. That oyster shell berm is actually all the refuse of Native Americans that lived there and ate oysters on the half shell 24/7, 365. And you can see the artifacts. There's pottery and firecrack rocks and projectile points and stuff. So they're good analogs to what probably occurred out there. What about the projectile points and their age? There are several points. There are three here. This is the obverse and reverse image of the same projectile point that span a period of time. These here happen to be about 13,000 years old. 13,000 years ago, and you can see the map to the left here, 13,000 years ago, sea levels were about 150 feet lower than they are today. So Sharps Island was a peninsula. You had the Susquehanna River to the west, the Choptank River to the east. So the people that lived out there 13,000 years ago, it wasn't an island. Oysters, crabs, clams, and fish played no role in the reason why they were there. You get to about eight or 9,000 years ago, and sea levels are about 80 feet lower than they are today. And by then, you start to see the bay filling in. It was still low salinity. There might have been some fish out there on those lower terraces, those shoreline terraces, but Sharps Island per se was still an upland, way away from any, shall we say, saltwater resources. However, the people that lost this point there on that island may have exploited fish in those lower valleys. By about 5,000 years ago, you're getting sea levels about negative 35 feet. Then the bay starts to take on some sort of semblance of what it looks like today. It's a broad saline body. There would have been oysters, oyster reefs there, but Sharps was still connected to Tillman. And when you get about 1,000 years ago, these are the Native Americans that everybody envisions from John Smith. Sea levels were about 3 feet lower. It was probably connected to Tillman, but there would have been a creek to separating it. It's False Channel. There's a false channel there. So the island was connected, but it wasn't long where it was going to erode through. At this time, where the lighthouse is today was high and dry, no doubt. And then you get, in the 1600s, sea levels are about a foot lower than they are today. 1670, 1680. This is a pipe, a white kaolin pipe that would have been smoked by somebody living out there in the late 17th century. Then we get to these pipes. This is about 100 years ago, like 1905-ish or thereabouts. These pipes were probably lost out there at the time when they had the steamboat wharf, and that fishing club was out there catching fish on Sharps Island when those photographs were taken of the hotel. Then we get to the Navy's record when the Navy decided to bomb it and shoot it with machine gun bullets. These are the archaeological remains from there. You've got 50 caliber machine gun bullets. That's A. We got 20 millimeter cannon rounds. That's B. We have cast iron target bombs that had a 12 gauge shotgun shell at the end. So when you hit it, it blows smoke. And then there are lead bombs as well. Ironically, the earliest and latest human presence on Sharps Island consists nothing of projectile points. We have the 13,000 year projectile points. We have the 50 caliber projectile points from the United States Navy. For a few weeks in 1978, some of Sharps Island's archaeological record was exhumed from the bottom. I happened to be a young kid, and Mr. Freddie Sadler took me out there, and we dredged up bombs and 50 caliber machine gun bullets and some artifacts that were associated with the prehistoric folks that lived on this island. And we weren't the only people that dredged up stuff out there. There were other clammers, and I was able to document where things were found. And you can see here on the right-hand side where those things were found and dredged. Most of those things were found east of the island footprint. The 50 caliber and the 20 millimeter cannon rounds and the bombs were all where the last remnant of the island was located. But more importantly, there could be some drowned archaeological sites out there. But when you look at this map, I've also superimposed the oyster grounds that are recorded by the Department of Natural Resources. And ironically, where there was a lighthouse in 1850, there is an oyster bar today. So it shows you the transition from an upland plowed field to now being viable oyster ground. And presumably out there on that bottom, and those shoals is a lot of other stuff. So a lot of these islands are disappearing. I've told you that, but not all the islands in the Bay or Bay region are disappearing. Some are getting bigger. I was fortunate enough to be able to do surveys on the lower shore, and researched some of the histories of these islands. And one of the islands, if you ever drive to Virginia Beach, you go over, it's called Fisherman's Island. In 1670, there's nothing there. By 1807, there's a thing called the Isaac Shoal. The first land patent for what later would become Fisherman's Island was 33 acres of a sandbar called Isaac Shoal, and it was in 1738. Prior to that, there was nothing there. Here it is in 1852. You can see there's two sandbars with some marsh. You got Fisherman's Island, 1852, and you got the Isaac Shoal. These things begin to come together. You can see they're getting bigger. This is the 1869 to 1888 surveys. You can see the land's getting bigger. 1905, you have people out there. There's actually some structures out on the island there near where the bridge comes on to Fisherman's Island from Virginia Beach. And you can see a dock. It's getting bigger. 1907, there's more structures out there. It's even getting bigger. It's changing its orientation a little bit. By 1942, it's even bigger. There was no bridge to it at that time, but there were still people out there. And then today, there's a bridge that cuts across it. But more importantly, where no land existed in 1700, Fisherman's Island is now 1,850 acres of land. So this island was not there. So you're not going to find any 13,000-year-old record there on this island. You might find some 1900 record, but it just goes to show you that not all landscapes or not all islands are getting smaller. What this does show is that sediment from point A gets transported to point B, and this is an accretion area. And actually, if you look at the accretion rates, it's about 6.65 acres since 1738. Most of the accumulation has occurred between 1958 and 2011 at about 10.4 acres per year. And the reason why it's getting bigger and accumulating more is because we constructed that bridge there in 1960. So it acts as a sediment trap. So all of these islands had an archaeological record. Fisherman's Island has a younger one. This island here, James's Island, had an archaeological record. I've got a bunch of artifacts I found out there. And a lot of that stuff is disappearing. And just to show you some examples, we're going to go back through time. This is the casket of Sarah Bloodsworth. You can see it under the water. This was the lower end of Hooper's Island. Sarah Bloodsworth became part of the Hunga River watershed back in about 2000. This is a Phillips Cemetery. This is a grave shaft over on World's End Creek. This individual became part of the Hunga River watershed about 10 years ago. Here's a skull cap. You can see that sticking in a bank profile. This is just opposite of James's Island. This is an earlier grave. We don't know who this individual was. I can tell you by the casket construction, it was probably 1700s, maybe even 1600s. But you can see the top of the skull. This person became part of the Chesapeake Bay watershed around 1999. Here's another skull. You can see the mandible. This is Native American. This one's around 1,400 years old. This individual became part of the Hunga River watershed around 2000. Here's another individual. This one's a little bit older. You can see it. You can see part of the legs here. It's the shell midden. You can see the skull there. It's collapsed in. This one's a little bit older. This is probably about 2,000 years old. This one became part of the Hunga River watershed in 2016. Now, it's not only burials washing away. There are the features that people created. This is a shell refuse pit. I dated it. It's around 1300 Cal AD or 1350 Cal AD. This is the garbage that they ate shellfish and they threw it in a hole. And it is rotting out of the bank. This thing became part of the Chesapeake Bay watershed around 10 years ago. So it's gone, but I did date it. I had a lot of hard shell clams in it, so they're eating a lot of hard shell clams. Here's a projectile point in the midden. This one's down on the bay shore in Dorchester County. You can see a triangular projectile point. I dated this one too. This one's 950 AD, so it's a little bit older than the other one by about 400 years. Here's an obsidian biface. Obsidian is really rare. We source that obsidian There's some obsidian from New Jersey. I don't think there's any from Pennsylvania, but they're around 2,000 years ago. Obsidian's moving from the Yellowstone Plateau into the Ohio Valley, and it's being traded east. This one I dated, and this one's around 300 AD, so it's around 1,700 years old. And we know that this material actually sourced from the Yellowstone Plateau because I had it geochemically sourced. So not only we know how old it is, and it's contemporaneous with ones in the Ohio Valley, but we also know the source. It came all the way from the Yellowstone Plateau to Dorchester County. That's a long way. Here's a pipe. Now, this one's out of context here, but it's kind of cool. It's kind of hard to see it. I probably should have taken other pictures, but it actually has a turtle on it. You can see the leg, you can see front legs, you can see the head. It's a snapping turtle. This one's probably about 2,000 years old, 2,500 years old. Here, now we're going to jump back through time. Here's a projected point on the lower end of Hooper's Island. This one's much older. It's about 10,000 or 11,000 years old, eroding out of a shoreline there, silt-based. This thing and many other things have long since disappeared and now part of the Chesapeake Bay watershed. Here is I washed it off so I could see it. It was all covered in mud. But this is a Clovis Point. This one's about 13,000 years old. This one's down near Savage Neck, Virginia. This one eroded out of the bank the day a tornado went across Northampton County, Virginia, and I think that was in 2015. It was in July. I do know that. So this and others like it have eroded out of the bank. And if you believe the dates on this one, this is Parsons Island. This is an artifact that presumably based on the charcoal and the carbon associated with it dates to about 20,000 years old, if you would believe that. And we're still working on aspects of that. So synopsis: coastal landscapes can erode without evoking sea level, I'm going to use a geological term, transgression. You can have erosion without sea level rise. You don't need a rising sea level. Actually, it works much more efficiently when sea levels are stable. Coastal landscapes can accrete sediment without evoking sea level regression. Fisherman's Island didn't accumulate there because sea levels are falling. It accumulated there because of a circumstance of tidal action, the construction of that bridge. So Fisherman's Island is not because sea levels are falling. It's because that's what sediment is doing, considering the currents that are at the mouth of the Chesapeake Bay. And then notably, there are many variables that affect shoreline erosion. And you can't equate shoreline erosion with evidence of sea level rise. Don't tell the media that because they don't like that. And generally, people that are milking the system for grants because of sea level rise don't like it either. And then the loss of islands in the bay is not unique to the 20th and 21st century. I showed you histories of islands that came and went well before they even did maps. And all we have is the metes and bounds of a tax, somebody willing to pay tax on them. And the archaeology and the history of these island landscapes are disappearing. Just islands are disappearing at a market rate. For years, I've tried to get state agencies interested in this, and I've had some traction, but generally they don't care. Just let it wash away. And it's sort of the best analogy would be like watching the Great Library of Alexandria burn in front of you and you being an archivist. You're sitting there, well, I don't care, let it burn. And that's generally the attitude that I've received. So in many respects, I feel like those people in 1905 standing out on that little marshy tump on an island later became sharps. I feel like I'm isolated because nobody, I'm giving you the facts. I'm not giving you a story, and I'm not asking you for money. I could give a shit about your money. I want to be honest with you. But I've watched these landscapes disappear. I got paid via research grants to give the public and institutions information to illustrate a process and get an appreciation for it. So like myself standing on this marshy island, I'm reenacting what happened at Sharps Island in 1905. So that's about it, but we're going to have a pop quiz. And I think some of you attended my library thing, so you've got some insider trading. And the question is, which one of these islands disappeared first? Now that you've gotten this lecture, we have me standing on marsh in B, and we have me standing on a big elevated pile of silt loam. Note that the elevated pile of silt loam is well above sea level. The one that I'm standing on in B is at sea level, tidal marsh. So anybody willing to take a stab? Hey, that's right. Not only did that disappear, but the whole entire island behind me disappeared. That's James's Island. All those trees gone. There's nothing there. That picture was taken. I'm wearing chest waders, so it looks like I'm, Jabba the Hutt here, uh, but anyhow, so not only did that disappear, but all that landscape behind me disappeared. That marsh is still there, and these pictures were taken about 5 years apart. So anyhow, if there's any questions, have your people contact my people, or you can stand up.
So I'll start, and the question I'm left with all of this information and me as a non-scientist, is the issue that you're trying to portray to the community that we're not battling sea rise, but that we're battling erosion. And what's the point of that?
What's the point of that is to get you, images without any context, geologic context. There was one time I gave a lecture at St. Michael's, and I actually picked on Dave Hart and Tom Horton, and I showed the picture of the Holland Island house disappeared. And I know exactly where they took that picture. It's a very powerful photograph if you don't have the context. But I also showed them the entryway to the Maritime Museum, and I said, no more is the house falling into the bay evidence of sea level rise than the entryway to the Maritime Museum evidence that sea levels are falling. It's a bascule bridge. It's the Tillman Island Bridge. So images without any geologic context can be very deceiving. And the reason why I like Bodkin Island, when Jay Fleming shared those pictures with him, because I'd given him some for James's Island, I was like, dude, this is the best image I've ever seen. Because people talk about sinking, and the bulkhead didn't. It's still there. So the moral of the story is to take this information and make a good judgment call about, if you own waterfront property, how to deal with it. And just because, and I've told many individual who has erosion issues, just because you can run a front end loader doesn't mean you know coastal processes, and you can put big chunks of granite. I've seen people waste hundreds of thousands of dollars on a shoreline that was completely stable. I've seen people do the wrong thing. I'm down here dealing with situations with fluvial action, rivers, and there are things where I'm like, that's not going to be, that road's going to be gone the next flood. And then there are people who have waterfront properties. There's one down on it's on the northwest end of James's Island. The people that originally owned it were the Twining family. And they had me down there, and they said, what would you do to stabilize this shoreline? I said, well, I'm going to be candid right now. I said, it's a beautiful view. It's one hell of a view of the Chesapeake Bay. If you offered me this farm for $1, I wouldn't take it. I said, given the current rules that say you can't bulkhead is bad. I said, that's the only thing that will work here. And it actually is just a temporary stay of execution. It will disappear. And he goes, what do you advise I do? I said, doctor it up and let it be somebody else's issue. Or spend $5 million and try to stabilize it. I said, because it's going to cost you a ton, and it's not going to stop it. A colleague of mine came over, a historian. I said, we'll go down and see if it's working, because he installed it about, I want to say 7 years ago. Drove down there. There's a family coming out. I'm like, well, that's not him. And I knocked on their door, and they said, what are you here for? And they said, well, we bought this farm. I said, I said, let me predict. The riprap that was installed is failing. And they're like, oh my God, yes, it's all caving into the bay. And so currently in the Chesapeake Bay, the mandate is to do a living shoreline. I understand that. I like it. But it doesn't work in all situations. It would be like saying, hey, you all people have to wear a size 9 shoe. Some of you could tolerate it. Some of you have bigger than 9 shoes. They're not going to like that. And you can't treat shorelines the same way. saying, okay, we're all going to do living shorelines and we can only do riprap. So maybe I danced around your question.
Actually, that was a really good segue because I'm imagining that there are people here who have riverfront properties. I know of a couple of people, and the county tells them you have to do X, Y, Z. And too bad that they can't have a consultation that says, no, do A, B, C instead, and have the county allow them to do that.
I was an expert. I was an expert witness in a legal issue just about that, and I'll leave the guy's name out of it. And the planning and zoning in Talbot County said in the testimony, and I laughed, and it was a classic thing that I heard in elementary school. You know, if we let him do it, what's stopping us from letting somebody else do it? And I looked at him, I said, nothing. You can't treat shorelines the same way. I said, we've talked about this landscape. I said, how many landscapes in Talbot County have a 4.5 mile fetch out of the southwest? I said, there's probably a lot of them. Some of them got a little greater. How many properties have a windblown sediment deposit over a 2 million year old paleo channel of the Susquehanna River, and then underneath of that is some Miocene stuff that you could stick your hand in and pull it out? I said, well, now we're down to a fewer locations in Talbot County. How many of them have 18th century houses that are adjacent to that shoreline and could potentially crane in? I said, now we're probably down to one. And this is the one we're talking about. And I never forget the individual. I said, you should make exceptions, because if you try to jam people's feet in a size 9 shoe, it won't work. Now, he actually got his bulkhead. It was the first time that anybody in Talbot County got bulkhead. And I told the powers that be, I said, we kicked Talbot County's ass with that one. And trust me, a lot of these people that they appoint to those positions, and I'm going to be candid because I don't really care. Just because you've got a degree in environmental science, bachelor's degree, doesn't mean you understand these landscapes. I have no agenda in these. I just want to make sure that people understand what they can do properly to stabilize their shoreline.
Darren, I was just going to say that my understanding is when that shoreline, or living shorelines legislation went through, that it was set up to have exceptions, recognizing that every shoreline is not the same and that it won't work everywhere. And so I believe there is a process for making the case that it's just not going to be out.
It usually works. The individual that I represented had more money than God. So when you have more money than God, you don't have a problem fighting, up the chain of command. When you don't have more money than God, it's usually an issue. And, and I'm dealing with that down here in Tennessee as well. Not necessarily shoreline erosion, but river erosion. And you can really see down here what water can do in 4 hours. That's absolutely blows my mind.
Darren, I had a question. It's Trina again. Why is nothing done about the cemeteries and the caskets that you should, like, why weren't they removed and moved someplace else to the mainland?
You'll find that funny because down here, literally the other day, in moving debris, they found the headstone of an individual. We don't know where his grave is, but we found the headstone. And it's like a major, who do we call? Who do we call? And I'm like, so down here, when you're dealing with on the federal level, there's a lot of concern. Why wasn't something done? I'll be candid here. A lot of people in positions don't like to do work. So I'm writing a consult letter, and I'm trying to contact somebody who did embalming, because the individual was headstone. He died in 1998. So we're trying to find out where the damn cemetery was. In this situation, we can see the people in the bank profile. We can see the headstone, and it's like crickets. That's all you hear.
Yeah, because I know in New York City, when they were doing some construction there a few years ago, and they came across an entire cemetery, And they dug everything up, they moved it, and so I'm just looking at these pictures thinking, if we know the island's going and there's a whole cemetery there, why aren't we relocating it?
Yeah, I mean, granted, that you hit the nail on the head. Great question. I can be as concerned about it as you are, but it's like silence hovers the sky.
Another question. Oh,
Yes, question. Perfect.
Hey Darren, how you doing? It's Chuck.
Oh, fun.
Hey, it's interesting. On my property there on Harris Creek, I have, I think it's close to 1,300 feet. There's basically three sections of shoreline. There's one that's marsh, it's natural, been in 100 years, probably more. It is not going anywhere. There's about 500 feet of riprap rock, heavy, put in about 40 years ago. And then there's a part where it's high 8 feet and it's got a beach natural. So the county came out and said, don't worry about the riprap, it's going to be fine for another 1,000 years. We need you to put a living shoreline where the marsh is, and over here where the beach and the high ground, we want you to build a living shoreline. So I called a friend of mine who worked for the Corps of Engineers, who put in canals and a lot of stuff. He's retired, he's 85 years old. He came down and said, Chuck, don't worry about the marsh, it's going to be fine. Don't worry about the beach, it isn't going anywhere. You need to worry about the riprap. It's going to slowly collapse because it's in an area that is not, when they cut the shore to put it in, it was already, guess what? The marsh is still perfectly fine after 5 years. The beach and the high ground is actually growing out in, it's not losing ground. And the rock formation riprap, which is about 5 feet above the water, it's slowly degrading and the shore is declining behind it. So you're absolutely right. There is, all types of variations in these shoreline issues.
Yeah, I can tell. I mean, granted, you would know this. There's an island. It's gone now, just opposite of Coach's Island. It was called Goat Island, and Goat Island was marsh, and it had a beautiful coastal beach formation with dunes and a nice sandbar spit, what you would call tombolo. And the guy who bought it spent like, I don't know, a couple $1 million for the damn place, more money than God, But anyhow, he had me up there. And he was like, oh, what do I do to keep the beach? I said, save the island. I said, when that marsh disappears, your beach is gone. And he says, why would I want to invest in saving that? I said, first of all, it's deep off of it. It's exposed wave. It's been around a long time. Don't get me wrong. But I said, what I would do is do a coffer dam along the bay side. That'll keep the marsh there. That'll keep your beach there. Needless to say, he didn't pay any attention. Clearly, it was no, Doppler effect. The island's gone, his beach is gone. Boom, So I've seen it time and time again. Down there to Savage Neck, which is just landscape on the bay. It looks bad, oh my God. But it's not. It's stable. It's been stable for 150 years. It's so much sand there, you can't get eroded. I mean, just because you have a big boulder of granite, what is that made of? Particles. What is sand? A bunch of rock particles. In 2009, I was down there, and some people sold some lots, and they construct these breakwaters offshore using big chunks of granite. And I said, ooh, they are going to regret that. And I talked to one landowner. I said, dude, why the hell did you do that? He goes, well, that's what the contractor said. We need to stabilize the shoreline. I said, this shoreline is stable. I said, you're going to regret it. I said, your house will be in the bay. He said, oh, I disagree. I said, well, we'll take a bet on that. And what he did was change the whole sediment flow. It created a backward eddy, ate that area to the south out, and boom, his house fell into the bay. And not to revert back to Tillman Elementary School playground antics, I want to go down there and go, neener, 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 being the mature adult that I am, and tell him exactly, hey, it's not like I, did this for 15 minutes or got appointed to some position because, I don't know, I'm somebody's sister's brother's cousin who gets some, planning and zoning position. This is what I do. This is what I did for North Carolina all the way through. Gave him advice. He didn't pay attention. He suffered the ramification. Two individuals didn't pay attention. There are people that have paid attention, and they reap those benefits. I own coastal areas down in Virginia Eastern Shore. The reason why I bought it, because I wouldn't have to, I incorporate the knowledge so I can limit the amount of expenditure for investment along shoreline. And the place that I have, I did it intentionally because I want to say, you know, you don't think I know what I'm talking about? Let's wait this out. Let's wait out another 50 years, and my land will still be above water. All these sky is falling techniques that 50 years Dorchester County will be under water is just like the 1907 publication saying that, hey, Kent Island will be gone. Right over Kent Island, stop at the McDonald's, it's still there.
So we do have communities on the bay that have had flooding problems, especially in the past couple of years, like Annapolis in the harbor, St. Michael's harbor. Is there a man-made solution that won't have unintended consequences?
Well, I mean, like a lot of people try to mitigate, sea level rise is something totally different. The stuff with like the St. Michael's Harbor. If you keep it as a harbor, last I checked, if you punch a hole in the bucket and you put it in the water, what happens? Water comes in the bucket. There is nothing you can do to stop the fact that water will come through an opening unless you dam up the Miles River or dam up the harbor. But there are two things that I'll tell you about that people don't talk about. Actually, I had a graduate student, we were working on it before I did what I did. Remember I mentioned tidal amplitude. Tidal amplitude is the difference between high tide and low tide. In the upper bay, it's about this much, a foot. Lower bay, it's 4 foot. On the ocean side, it's 5 foot. Now, why is that important? Well, no one knows if the tidal amplitude has changed over time. However, there is one record, and it's for Tangier Island. And around the turn of the century, they had a program to measure the water variation over a season of a year. Now, granted, tides are usually mean tide is based over a 19-year lunar cycle. But they did it a year. And the tidal amplitude down there was about 1.98 feet. So it's just shy of 2 feet. Today, the tidal amplitude at Tangier Island is about 1.5 feet. Doesn't sound like much, it's about 6 inches. But for 6 inches of water that's no longer going out of the bay there per 1 square acre of land, that's about 180,000 gallons of water less going out of the bay. Why would there not be the same volume of water going out the bay? Let's go back to Fisherman's Island. What happened in 1960? They constructed that bridge across the mouth of the bay. That bridge across the mouth of the bay is a giant sediment fence. The bay is shallower there today than it was prior to 1960. Fisherman's Island's gained over 1,000 acres of land since 1960. So when you make the mouth of the bay shallower, the water going, out of the bay at low tide, because tides are driven by what's happening in the Atlantic Ocean, not what's happening in the bay. When that gyre, that amphidromic point out there in the ocean, which is basically spinning around and causing low tide and high tide, when that water gets low tide, it's coming down the bay. It has to rise over a sill that did not exist prior to 1960 or back in the turn of the century. So if you reduce the tidal amplitude in the upper bay, you have a compounding effect. You have more water in the bay at any given point in time. Remember, more water in the bay, you have more likelihood of flooding. And you have also more likelihood of erosion, because remember what I said, erosion is like a hammer hitting the wall at the same spot. You also have less flushing. The bay is a giant toilet. I like what Willie Rowe said in his Growing Up in Tillman. He said, I know what happened to the bay. It's a giant septic tank. He's absolutely right on about that. The bay is a big toilet. If it doesn't flush effectively, if you have a toilet in your house that doesn't flush effectively, what do you have? So if less water is going out, you have less flushing. And so it's an interrelated compounding effect. That bridge was constructed in 1960. Why is that important? Because they didn't have to do an environmental impact statement. They have to do it in a NEPA review. The Bay Bridge Tunnel was constructed before any of that was needed. And now, potentially, we are suffering the ramifications of that. Areas that, are more regularly being flooded by wind transfer of water. Wind transfer of water is not sea level. Wind transfer of water is just when it blows, 75 miles an hour to the northwest, it blows water down the bay. When it blows out of the south, it blows up the bay. If you look at you can actually look at it online. Hurricane Isabel, I remember Isabel. I'm pretty sure some of you do too as well. If you look at Hurricane Isabel, the reason why there's differential elevations in the water is wind transfer of water. So when the wind was blowing out of the east, Pocomoke Sound up near Williams Point, which is headwaters of Pocomoke Sound, the difference between high and low tide during that storm was maybe that much. Same latitude on the western shore over near Gloucester and Matthews County was about an 8-foot tidal differentiation. That was the wind pushing the water that way. And the base is a big bathtub. And if you want to experience it, you want to experiment in that, fill your bathtub up to the top, go to, I don't know, Lowe's or whatever, get an industrial fan, turn it on high, and watch what that fan does to water. It's sachet. It's what it's called, the term sachet. It happens in the Great Lakes. It happens in the Bay. And it happens all the time in the Bay region. The geometry of the shoreline, the bathymetry, all of those things play a role. But when you have less water going out of the bay, you're more likely to have flooding events. So when you get back to St. Michael's, how are they going to alleviate water coming into the streets? Unless you can dam up the mouth of the bay or dam up the Miles River, you're still going to have that. And there's no construction you can do there at that harbor that's going to stop that. And it's not sea level rise. It's the changing of the tidal amplitude. I mean, I'm not doubting that sea levels are coming up. It's about 10 centimeters a century. I've done analysis down in Virginia, done tons of dating and coring. But when you see sort of using tide-based sea level records against geologic-based sea level records, you're going to have some issues. Just like I said, tidal amplitude, lower bay is greater. Tidal amplitude is upper bay is lesser so. So if you use mean tide, what's the sea level in the bay going to be? It's going to be like that. And the last I checked, water forms a common level. So anyhow, it's a very complicated thing. I could teach a whole class on this, and trust me, I could bore you to death to the point where you fell asleep and I could watch you drop. But all of these things are very complicated. And what happens locally is one thing. What happens, we have no control of what's happening at the mouth of the bay. And they're all interrelated. And when somebody says, give us a quick fix, and they give you a quick fix, usually it won't work. So,
Darren, I just want a point of clarification. So you can get land loss through coastal erosion, but you can also get land loss of the low-lying areas through actual sea level rise.
Oh yes, you can. You can.
You're not denying sea level rise as a process.
I'm not dying. Yeah. Absolutely. And you remember I showed you on that one map of Sharps Island, you can see those USGS triangulation markers. All of those triangulation markers, they generally are a bronze plaque. They're dated. And they'll have the date on them and they'll name them. They're usually a unique name. I have one in my house named Paul. It's 1933. I found a ton of them over the years. And they're easy to find because all these metal detectors. You're like, oh, there's one here. And you find it and you scoop around. Mockhorn Island is on the ocean side. This is Virginia, lower end of the bay on the ocean side. In the area where it's professed that in the last century, we've had 1.5 feet of sea level rise. Last 100 years, 1.5 feet. That's what the tide-based model suggests. On the northern end of Mockhorn Island, there's a linear ridge of trees. Goes right straight. It's right in the center of the island. Goes right straight out. They're usually eastern red cedar. I can see the triangulation marker that was plotted there in 1898. Bronze plaque dated North Mockhorn. I found that triangulation marker dated, still has a little triangle with a circle, dated 1898, North Mockhorn date. In the map, it shows it at about 100 feet north. I did a georeference map. I calculated about 100 feet. Could be 101, 105, I don't know. But it's about 100 feet. Went out there with a metal detector, found it. Boom, there it is. You know what? When you exposed it, there was about that much tidal marsh silt over top of it. Now, I have a problem with that because if sea levels have come up 1.5 feet, tidal marsh accumulates. It grows vertically as a byproduct of detritus runoff and blah, 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 sort of combination thing, anaerobic conditions, and therefore it grows vertically. So when you look at that picture of me standing on that island in the Hunga River, that island with tidal marsh is expressive of sea level. To get tidal marsh to form, you need salt water. You don't see tidal marsh forming in 40 feet above sea level. It's right at sea level. The cartographers that created the first maps of the Chesapeake Bay realized that. They realized the problem with using tide models. So what they did is they put these triangulation markers in the marsh, and they shot those measurements to get an elevation map. And those triangulation markers still exist. There's hundreds of them, not thousands of them. I found them in Dorchester County, right on the surface. 1958. I found them on Tillman, 1933. I found them on Mackinac Island, 1898. And guess what? They're still on the surface of the marsh. So if sea levels came up, they shouldn't be on the surface of the marsh. They should be beneath marsh. So I throw that out there. I actually wrote about that in one of the survey reports that I did for the Commonwealth of Virginia, and also for Maryland, for Dorchester County, because it was this erosion and sea level thing. And said, hey, if you really want to calculate sea level rise, go out and find these benchmarks. These benchmarks were installed historically. They give us a glimpse as to what the surveyors thought sea level was, because when you see a topo map, a USGS quadrangle, they show a topo line. That topo line is based off those triangulation markers. So anyhow.
So I know we have a question here in the room still, but I want to ask the people who are on Zoom if any of you have a question you want to ask.
Silence hovers the sky. Silence hovers the sky. It must be my bubbly personality. I also haven't had lunch, so right now I'm hangry, if that means anything.
So here you go.
I just want to follow up on, I'm just still fascinated with all your arrowheads, and knowing that you've pawed your way through them probably many, many times, can you interpret, because of the actual arrowheads themselves, about any observations about what they were used for?
Oh yeah, absolutely. Some of the, like the one that I showed that's like 8,000 years old, had all the teeth. You find a lot of those when you find them broken. When you find them complete, you really can't tell what they were used for. You really got to have them when they struck something hard. And some of those things show hellacious impact fracture. So if you take a piece of rock, it's like a piece of glass, and you throw it at a concrete wall, it shatters. It goes into bits. And the broken ones tell us more about the function of the actual arrowhead. And I use that arrowhead term. A lot of them were knives, especially the bigger ones. The smaller ones, the more daintier ones and the ones that are kind of narrow are generally projectile points, and I use that cautiously. And the question is whether they were arrowheads or spear tips for spear points. It's kind of hard to determine, because when you throw a spear with a spear thrower, it's going to give you the same impact fracture as you would see on one that was shot with an arrow hitting the similar object. And like I say, a lot of them are asymmetrical. They've been resharpened, lopsided. That's not what you would expect on an arrowhead. That's more what you would expect with a knife, when you resharpen one side more so than the other. One time I gave a lecture and I brought out a full grooved axe. Everybody assumes a rack. And I said, okay, what is it? Of course, everybody says it's an axe. I said, prove it. And again, it was silence. And I said, this broken axe will show that. My father and I, over a period of years on a marsh down near Tillman, I never forget, we found it was an axe or a piece of one, and it looked like it had struck something going 110 miles an hour, and it literally exploded. Boom. And so we could see a piece of the groove, but the piece that we found was patinated, so we knew it was an old break. It wasn't something Farmer John struck with his plow. But over the years, I found more and more and more pieces of them. They're all different colors, and it put it together. And eventually I got, 90 pieces of a 100-piece puzzle. I'm still missing a few, but you could see the reason why it broke. It struck, the person had it in half and they struck something hard, could have been an oak tree or whatever, and it just exploded. If there's a time of what you can document as prehistoric profanity, that would have been the moment, because that thing was essentially destroyed. And so when you find a complete one, it's nice. Oh, it's pretty. But usually the damaged ones give you more insight into actually the function. So when you look at that sample from Sharp Sound, the unfortunate thing is a lot of them are complete. So when they were out there, like, oh, I don't want the perfect one. But looking from other sites, you can tell something about the function.
So we're about ready to lose Zoom time. Any last question? No burning questions? We don't want to leave any burning questions with you. So,
Oh, no. But no, I appreciate the chance. I mean, granted, it was, and trust me, I got to put accolades to accolades. Earlier on, I think it might have been, somebody said something about the exhibit at the Tillman Island Waterman's Museum. Like, oh, you contribute a lot. I contributed doodly squat to that. All I did was give it to Bonnie. And it would be kind of like having your room in your house painted. And you go to Lowe's and you say, thank you, Lowe's, for doing a great job painting my house. You know, Lowe's didn't paint your house. It was the painter that did a job. And, you know, all I did was I gave them the cans of paint, and Bonnie did what she did.
we are all looking forward to going out there on Friday. Little field trip, go a little early. It takes about an hour from Easton to get out to Tillman Island. If you want to go for lunch, go to 2F by C and join up with our friend Henry for lunch. And then you'll have, if you get there by 12:15 or so, you'll have plenty of time to enjoy lunch before going back over to the museum. So we're looking forward to that trip and seeing what's there at the museum. And despite your saying you had nothing to do with it, the main reason why we have you here today, and the fact that the folks at the museum helped with that. So thank you very much.
It takes a lot of people, and thanks for giving me the opportunity. And hopefully, people don't hold my bubbly personality against me.
Well, we learned a lot about sea rise and erosion, so that's great. So thank you so much.
Take care. Sure. I will catch you later.
All righty, bye.
Log it off. Bye.
Log it off.